Welcome to video 2. Remember, here our objective is to get our system to row canonical form. So in order to get our system to row canonical form, the pivot variable needs to be the only non-zero entry in a column. So with regards to this matrix that's already in echelon form as we reduced it in our previous lecture, in order to get 0 above the pivot -6, we need to multiply row 1 by 6 and add back row 2, right? So what we have is that 6 row 1, row 1 will change to 6 row 1 plus row 2. So what we're going to have is that we're going to have 6, right? 6 row 1 plus row 2 will just be 6. 6 plus 0 is 6. And 6 minus 6 is 0. And 6 plus 1 is 7. And -12 plus 4 is -8. So we're done here. 6 is the only non-zero entry. -6 is the only non-zero entry. And it happens to be a pivot. So we're done. The only thing that's left is to for this column is to get it to +1, but we shall suppress that for now, because once I get my pivots variables to 1, it means I have to deal with fractions, and I don't want to deal with fractions. So what's left is to get everything, since -3 is our pivot, what's left is to get everything above 3 to be 0. So in order to do that, we're going to multiply row 3 by 2 and add row 3. So what's going to happen is that row 2 is going to change. So in the next slide, we'll see how it has changed. So what we get is 0, -18, 0, and 16. If you're not convinced, we just have row 3. 3 times 0 is 0, we get 0. -6 times 3 is -18. -18 plus 0 is -18. 3 times 1 is just 3, plus -3 is 0. 3 times 4 is 12. 12 plus 4 is 16. That's how we arrived at our new row 2. Now the objective is to get 7 to be 0, right? And in order to do that, we need to get 7 to 0. And in order to do that, we need to multiply the row 1 by 3 over 7 and add row 3. We need to multiply row 1 by 3 over 7 and add row 3. So 6 times 3 over 7 will be 18 over 7 plus 0, it will just be 0. 3 over 7 times 0, it will just be 0. We add 0, we get 0. 3 over 7 times 7 is 3. 3 minus 3 is 0, and we get 0. -8 times 3 over 7 plus 4 will just be 4 over 7, right? Then what we do is, this system is not yet in row canonical form because our pivots are not 1. We need to get all the pivots entry to +1. So what we do with row 1, we divide everything in row 1 by 7 over 18. So we will get 1, 0, 0 times 4 over 18. 4 over 7 times 7 over 18 is just 4 over 18, right? And row 2 should also change. In order for row 2 to be, in order for this pivot to be positive 1, we multiply it by a negative 18th. So we get 0, 1, 0, right? Negative 16 over 18. And in order to change this negative 3 to 1, we need to divide by negative a third, right? When we divide by negative a third, we get 0, 0, 1, negative 4 over 3. If we simplify further, we can see now the system is finally in row canonical form, and we can read off the solution on the matrix. For instance, x is equals to 2 over 9, y is equals to negative 8 over 9, and z is equals to negative 4 over 3. If we go back to our backward substitution solutions, we will see that these solutions, this solution is the same that we obtained with the method we used. Recall, we got z to be negative 4 over 3 once our system was reduced to echelon form, and then we solved it by backward substitution, and we got x to be 2 over 9, and we got our y to be negative 8 over 9, which is exactly the same as what we have in the matrix that is in row canonical form. So obviously this completes our first lecture. So the most important concepts that I want you guys to know is to reduce the system of linear equation into its row echelon form by using Gaussian elimination. And you should also know to reduce the system to its row canonical form by using Gauss-Jordan elimination. Moreover, you should be in position to solve systems of equations by elimination and substitution. So these are the most important concepts that I want you to be comfortable with in this lecture, and I will ask such questions in an exam setting. Thank you very much for listening. I'll see you in the next video.